Fundamentals of work. In this lecture, I am going to discuss about fundamentals of the work from the physics point of view. Okay, so let's start with the lecture. So basically, I'll start with the examples in our day-to-day life that we can define, or we say that that is a part of the work. Okay, I have taken some examples like lifting a box of books. Okay, farmer plugging the field, coolie carrying some load on his head, weightlifter holding the mass, pulling off lawn roller, and pushing a wall or mountain. So this is the thing that we can define in our day-to-day life, that okay, this is a work. But in the language of physics, the definition of work is a bit different. All the activity that we perform in our day-to-day life cannot be considered as a work. Okay, so in the language of physics, work is always done. Okay, please mind the word, work is always done. And when the work is said to be done, work is said to be done by a force when a body is displaced actually through some distance in the direction of the applied force. Means whenever you are applying the force and the body is moving in the direction of the applied force, then and only then the work is said to be done. Now the example that I have taken here, pushing a wall or a mountain, is not a part of the work in the language of physics, because if the wall or mountain is not moving in the direction of your applied force, then that cannot be considered as a work in the language of physics. Okay. Similarly, if you are lifting a box of books, okay, and if you are lifting vertically upward and then you are moving, that can also be not considered as a work. This thing you will come to know when you will read, when you will study more depth about the work. Okay. So as per the definition of the physicist, definition says that work is mathematically equal to the applied force and the displacement. Means applied force is F that you have applied here, and displacement is X. Now for the purpose of example, for the purpose of your understanding, I have taken a very simple example. I am having a block. Okay, block is at position A, and I have applied a force F. This block has moved from position A to position B, and the displacement is X. Okay, so in this case the applied force is F, and the block has actually moved, actually displaced, in fact more precisely, to a distance X. Okay, so in this case the work done is F into X. But if the block is not having any displacement, means what I mean to say, if X equal to 0, then W equal to 0. This is the mathematical, or you can say the definition of the physicist of work in the language of physics, or in the world of physics in fact. Okay, and work is said to be done when a force is used to move something. Okay, like opening the door, climbing up the stairs, throwing a ball. These are the examples whenever you see the some displacements. Okay, like climbing the upstairs. In the climbing the upstairs, when you go from down to up, okay, in this way, for example, if you are climbing upstairs and you are going from down to up, so you have some displacement, because in this condition this was your initial position O, and now you have reached to a position A, let's say. Okay, so actually you have some displacement. Now it depends upon that in which what is your actual displacement and at what instant of the time. Okay, similarly when you throw a ball, so when you throw a ball, okay, like this, when you are having a ball and when you are throwing a ball and it is going towards a wall, then if due to your force, you have applied a force F, and if due to your force, if the ball goes to a displacement of X, okay, then in that case the work done by you in throwing the ball is F into X. Okay, so in this way we can say that work is said to be done in the language of physics by a force when a body is displaced actually through some distance in the direction of the applied force. Now in contrast to that, if this is a ball, you are applying a force in this direction F, but ball is moving in this direction, means there is no effect of your force on the direction of the movement of the ball. okay, then in that case your work done equal to 0, because this is because your force has no effect on the displacement of the object. That's why I said this is a very important, and I have just underlined all these three things for the purpose of your concept. Okay, displacement is required, applied force is required, and in the direction, please mind the thing, in the direction. Okay, please mind this thing, this is very important part. So this was the all about the fundamental of the work, and I think now the fundamental of work is now pretty much clear to you. So this was all about the fundamentals of the work for this video lecture, and thank you so much for your patience, and please take care of yourself.